Okay guys, today we're going to be talking about in this lesson how to change from a standard form of a quadratic equation to a vertex form. There's a lot of advantages to being able to do that. One, if you have a vertex form, by definition it's very easy to find the vertex, which is a very important point. It's the point where the quadratic equation is going to turn on the graph. It's the minimum or maximum value. There are a lot of application problems that go with that. When you have something in standard form, it's not as easy to find that. It is easier to find some other things in standard form. So I'm going to go overview about what each of the forms are, and then how do we convert from standard form to vertex form to find that useful. So you see up here on the board, the first thing you have is we have a review of standard and vertex forms of quadratic functions. Great, that's what we just said it was going to be. Next, I have a standard form here and I have a blank. On your note sheet, you're going to want to fill in what is standard form. And standard form is not what it says in your book. Our book, for whatever reason, decides to call vertex form standard form, and that's very confusing because it's the only book I've ever seen to do that. I will be referring to standard form by what almost the consensus is with everyone else. And here is standard form that I want you to call standard form and use. It's a function, so we start with f of x. We got ax squared plus bx plus c. Please make sure you fill that in on your note sheet so you can have credit for that, and also so that you will have that handy. It's in your book as well, but again, they're a little confusing with their terminology, so go by this. Their standard form. Vertex form is going to look a little bit different. There's going to be some different letters in it, but we'll explain what they mean as we go through it. So here's what vertex form is. F of x, you'll notice that it's still going to start with an a. This a and this a are the same thing. They don't change. So that's a nice thing about it. We know what that is. If we have standard form, we can find the leading coefficient of vertex form as well. We still have our x, which is great. And then we have new things. X minus h squared plus k. And people look at this sometimes and find that intimidating. But what we can talk about with h and k is those are the coordinates of the vertex. So we don't have to talk too much more about it other than we can say hk as an ordered pair is the vertex. So we can see that we have f of x, a, and a. We have x, and then the h and the k kind of take the place of the rest of this stuff because what they are doing is regrouping them so that you have a squared function. Once you have that, it's going to be easy to evaluate things. So what we're going to do next is run through a couple of examples of how to change standard form into vertex form. And if we can do that well, then we've got this taken care of. It's a pretty easy idea, but we don't want to get confused in the process. If you didn't get any of this down yet, I would pause the video at this time and get a copy down before we move on to the first example, which I'm going to start now. So you can see on the first example here, we have something given to us in standard form. When this is in standard form right here, and what it says is negative 2x squared minus 20x minus 44. When you look at that, you can see that the leading coefficient is negative. It doesn't matter if it's positive or negative as far as what we're going to be doing. It works the same either way. But it might be helpful, especially when we're learning this stuff early on, to label these. And remember from over here, standard form is ax squared plus bx plus c. I'm going to go ahead and label these numbers. A, b, which is negative 20, negative 2, and c. Now, they just happen to all be negative in this problem. They could all be positive. There could be a mix and match between negative and positives. It doesn't matter. You just take the numbers as they come. H, we talked about over here, is going to be the first thing we have to find a new vertex form. H is going to be the x value of the vertex. So the way we find that, h is always going to equal negative b, the opposite of b, divided by 2a. So you double that a, and then you go ahead and do this division problem. We'll do that now, but what this is going to tell us is this is, again, the x value of the vertex. And in this case, that's going to be negative 20, which is positive 20, divided by 2 times negative 2. So since you're all super good at math, you could figure out that pretty quick and get negative 5. And that's h. Again, you can refer to negative 5 as the x value of the vertex, which means this parabola is going to be shifted to the left from the origin 5 units, and then up or down a certain amount, which we'll find now. When you do an ordered pair, the x is the input. We have found the x value, that's the input, and we have a function that will allow us to find the output. So what we're going to do is we're going to take that -5 and we're going to put it right into the original function and see what happens when we evaluate that function. So we're going to do f of -5, which in this case, -2 times -5 squared minus 20 times -5 minus 44. And these numbers are larger numbers than what you might see in some of the examples you do in your book, but I think it's easy to go from larger numbers to smaller numbers if you see those. The main idea is that you can find -b over 2a and substitute that back into the function to find the value of k. So what we've got here, we've got -2 times 25. We've got plus 100 when I multiply those, minus 44. So -50, that makes it 50. Minus that equals 6. And altogether then, what we have found right there, that is that number k that we were looking for. That is the y value of the vertex, the output at the vertex right there. So we know now that the vertex was at -5, 6. And we can go ahead and write that if we'd like, because it helps us go for the next part. The very last thing we do, because remember that in this problem we were converting from standard form to vertex form, we're going to go ahead and write it as vertex form that we see right here. Up in this problem, -2 was the leading coefficient. It will remain that way right here. So what we're going to have with this one is it's still f of x. That part didn't change. We've got -2 because that was -2 right there. In parentheses, we're going to have x minus the opposite of -5. And when you subtract the -5, remember that's going to be written most easily as x plus 5. That gets squared. You don't actually do that squaring, you write that in terminology because you can notice in vertex form it's right here. Finally, we found that vertex to have a y value of 6, so we're going to throw that back in here at the end when we substitute it back in, and this function, the circled one, and the function at the top are exactly the same in terms of a graph. They have the same characteristics. If you plot one and plot the other, they would be the same graph. And that's the first example. What I'd like you to notice on this, because it had a negative leading coefficient, this would be a parabola that's going to open downward, like that. And we would know that that point right there is the vertex. And since we know that right there, that's -5, 6. And that's where that would be. We're going to go through one other example of this, but if you haven't gotten this one down, this would be a good place to pause the video and make sure you have the notes from that question down, so that you'd be able to follow along with those if you had to look back at them later or use them in class tomorrow when you're going through the work. Okay, I'm going to remove example 1 and put example 2 up here now. When we do example 2, you're going to notice that it looks a lot the same. Remember, this is called standard form again because it's ax squared plus bx plus c. And that's the standard form of a quadratic that you would have in this case. What we're going to do with this one, we're going to start with -b over 2a. If I were doing this problem for a homework assignment to turn in, I'm going to write this one as this is the work I would expect to see, so I could tell that you went from step 1 to the final product and make sure you get an understanding of it. So we would start with the h value is going to equal -b over 2a. So there's b. 2 times 3, and 24 divided by 6 is 4. So I know that my vertex has an x-coordinate of 4 based on that. Now we can go through and figure out what the other part's going to be by finding and evaluating f of 4. Okay, when we go through this stuff, we're going to figure out these numbers, and it's sometimes helpful to go a little bit at a time. 3 times 16 here will be 48. 24 times 4, it's going to be a -96. And all together with this one, we ended up with 7 is the final product of all that. And you can check along with that to make sure that it's correct. But we got a 7 there, so I know that when the x value is 4, the y value is 7, and I know from this part that that's the vertex. Wrapping it all back together to figure out what vertex form would look like, we would say f of x equals 3 because this leading coefficient was 3 and it doesn't change. X minus 4, that was this, 4. And then we got a plus 7 at the end. And our vertex is at 4, 7. This leading coefficient was positive, so I know that this parabola would basically, a very quick looking graph right here, it would start at 4, 7 and open upward. So that's kind of a crude graph right there of what this one would look like. I'm not asking you to do that right away, but that is something that we'll be getting into as we look at those with Vertex Form. At this point, you should make sure that you have that copied down. Again, we'll be looking at a few of these tomorrow. You're going to look at your assignment sheet and see what I've given you, and that we'll be working on tomorrow so you can get a head start on that if you like. Thanks for watching, and I hope you understand changing from standard to Vertex Form a little bit better now. All right, bye.